Okay, good afternoon. The problem we had, we run out of. Pardon?
Mic closer to the mouth.
Okay, time was the resources that we lacked the most. We would like to present something very simple. At least we are dealing here with pixels. You have heard about. It's not very convenient. Yes, it's my beer. Okay, I understand. Okay, we are dealing with printed sheets, more precisely sheets of music, of paper, I should say, which are scanned, and from which we try to retrieve semantic information, which is called OMR, optical music recognition. This is something which is still a research area, to be frank with you. What is new is that there is a possibility to apply new technology coming from deep learning to this problem. And here we have defined a very limited, very precise objective, which was to try to use what we call full context training. I will be more specific in a moment. But before that, let me present you the participants. So Sanu, I'm sorry for your name. Sanu is okay, but for the rest I cannot. Here is Sanu. Werner, where is Werner? From MuseScore. Nicolas also, where is Nicolas? Here from MuseScore as well. And Hervé Bitteur, myself, from Audiveris. Bon, okay, I will stay here. Okay, so the problem we have, and I think that Thomas was right when he said that the more data we have, the better results we are able to get, and this is something which applies also here. So what we need is something is a way to generate images of scores, but something that we can master. We're looking for symbols, and we're interested in the symbol itself, and also what we call the context, which are the surrounding pixels. Let's say something like a rectangular area around the symbol. So we wanted to have a bunch of these examples. So the question was how to generate these ones. So generation of images, we had several possibilities. We have addressed the first one. Since MuseScore has a knowledge of semantic music information, MuseScore is able to build artificial or synthetic images based on these scores. So these images are artificial, right? But they are very clean, okay? And we can master them easily, and we can generate really hundreds, thousands of them. Problem, this is not it's not wide enough to represent the wide variety of printed sheet music, especially the one which have been distorted or badly printed, whatever. So the idea was also to use a variation in the font, which is being used to provide the images. So even if it is the same symbol from a semantic point of view, the appearance may be a bit different for the classifier. Another thing which we have begun to implement, but which is not all taken into account yet, but you will see some result from that, is to take the images out of MuseScore and modify it in various areas. There are possibilities to modify it, adding some kind of a nose, Gaussian, salt and pepper, this kind of thing. It's very easy, and it does not modify the coordinates of the symbols, and we have other possibilities where you slant or you distort, you really modify the sheet and of course the coordinates. Okay, we will present some examples of that. Okay, so once we have this, I would say, this data set of images, and for each image, which is the image of one sheet of music, we have a list of symbols which are in this sheet with the precise coordinates, precise bounding box to be precise, for each of these symbols. Okay, so what we need is to extract features, to be precise, the very pixels of the context for each and every symbol, and we store them in a CSV, a comma separated value, a CSV file. This is not mandatory, but it helps because it is just an intermediate data which we can validate. And the first validation that we made was to read back the CSV and to generate some what we call sub-images from this information, just to visually check that the data was correct. And the final task that we had to carry was to take as input these features and feed them into the neural network and start the training of a neural network. Okay, so here are some of the results. Show yours. Go to distorted immediately. Okay. So we stop. Okay. Anyway. So this is just an example of one sheet of music that Werner from MuseScore generated. I don't know if this is real music. No, it is not. This is just to test that the framework works. You can try to hear that, but I think this will not be very pleasant to hear. But what you can see is that this image is perfect. The symbols are very clean, very neat, etc. Okay. On top of that, can you show the? Yes, this one. Okay. So it's the same image as before, and you can see for each and every symbol we have what we call the bounding box. So we have a C clef there, we have a key signature, a time signature, then a node head, and so on and so forth. Okay. And for each of these symbols, we extracted these sub-images. Could you show the images? It's in the folder sub-images. Okay, here they are. So we have a bunch of them. Okay, could you just stop a little? So you can see that this is a context, which is a rectangular area with always the same width and the same height, and it is centered on one symbol at the middle of a symbol. Okay, here you have a node head, here you have a F clef, here you have a key signature. So what is important here is to be able to work and to recognize the symbol here, even though there may be some pixels around that. Okay, what else? Distortion. What? 1 minute. Yes, this one is good. Okay, this is an example of a real distortion, and as you can see, no, it's not distortion. It was just rotated. Okay, anyway, so the purpose, because this may happen. Okay. And as you can see, the coordinates of the elements are slightly modified. Okay. Now we provide this to the. Let me do that. Where is it? Oh merde, il est là. Attends. No, this one. Okay. And check CSV, OMR dataset. Okay. Okay. So we are just launching the training of a neural network. Where is it? No, not here. Yeah, good. So what you can see here, it's the initial error output. It's the output of the neural network, and we start with something like 5 some, and then it should gradually descend to something like 0. Can you show problem? Okay. 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 We are. What else? The framework is more or less okay. We can, of course, generate much more image than the number we were able to produce this morning, and then it's only a question of having all the symbols really described and having the network being trained on this. So for the very specific goals that we had, I think the hack, even if we had no time for that, is more or less working. So thank you for all the participants. Thank you.